I am Ray Resendes, R-E-S-E-N-D-E-S, and I'm Chief of the Intelligent Technology Research Division at the U.S. Department of Transportation National Highway Traffic Safety Administration, NHTSA. NHTSA is exclusively focused on safety. So within it, we have been working in the ITS realm for over 15 years, and we originally started looking at vehicle-based sensors. We run nearly 20 field operational tests of things like forward collision warning, lane departure warning, and demonstrated on real roads with real drivers that these systems are effective. And out of that, technology has evolved to become to provide vehicle communications. So the previous systems worked on radar, other vehicle-based sensors, and now we're transitioning to vehicle communications. So you replace the need for one or more relatively expensive sensors with relatively inexpensive radio that can provide up to 360-degree awareness around the vehicle. And from that, you get the capability to provide an entire suite of integrated safety systems that are driver assistance systems to help the driver avoid crashes. Yes, and the United States is unique and lucky in that in 2000, the Federal Communications Commission dedicated 5.9 gigahertz for the use of dedicated short-range communications. And in their ruling, they encouraged the use for safety applications. It can be used for mobility and other applications, but the primary use is public safety. Well, there's two big parts. The first is, can we develop a robust interoperable system so that any system that's on any vehicle, make or model, developed by any manufacturer, can talk to any other vehicle. And so we have a lot of work with the industry to develop that. And there's a myriad of issues, such as the security. How do I make sure that you're giving me a real message, that either a hacker hasn't messed with it, or you just have a bad sensor on your car, so you're putting out a bad message? How do I ensure that that's not happening? And how do I ensure that I can hear you when I'm in a Manhattan intersection, which may have 200 cars around me? So how do I hear all of those vehicles, and how can I make sense of it? Then, once you get past those very technical hurdles, there are the application issues of, now that I have this information, what can I do with it? How can I present a useful warning to the driver? So that's really up to the vehicle manufacturer to be able to leverage this capability of vehicle communications so that he can offer safety to the driver. It is primarily focused on what we call crash avoidance. Crash worthiness, helping you to survive a collision, is very much a vehicle-based technology. We have made great strides in that area. There's still more work to be done, but we're in really good shape there. Vehicle communications, is unique in that it's one car talking to the other. So it's really to prevent vehicle-to-vehicle crashes. I think we will evolve to that capability. Initially, the benefit of vehicle-to-vehicle is we're dealing with the vehicle community. So we just need to get the radios deployed on the vehicles. When you open it up to the infrastructure, you're bringing in a new set of stakeholders. So it's really not even a technical issue. It really gets into the policy issues. But once the vehicles are equipped with the DSRC capability, then the infrastructure providers can pick and choose how they want to deploy their part of the system, which will use the same radios, the same standards. That whole interoperability issue will have already been solved for them, and they just need to develop their unique applications. And that would be things like intersection collision avoidance, where you need to know the signal phase and timing from the traffic signal so that you don't run a red light. Okay, we're looking at the collision that's caused by inattention. So the driver is either distracted by his cell phone or just isn't paying attention. So they're proceeding towards a red light, or they're proceeding towards a light that by the time they reach it is going to be red. The signal is constantly broadcasting what we call signal phase and timing. So is it red, yellow, or green? And how long is it going to be until it turns to the next phase? That message goes to the car, and then the car processes a warning because the car knows where it is, it has a map of the intersection, and it knows how long it's going to take it to reach the stop line. And if it can't make it to that spot before it's going to turn red, it issues a warning to the driver. The warning could either be visual, audible, or haptic, which is a vibration in the seat. Our work has shown the most effective warning is just the voice coming out of the dashboard telling the driver to stop. We actually demonstrated a working prototype at Virginia Tech in Blacksburg, Virginia 2 years ago. So the system exists. The Europeans and Japanese have variations on the same theme that they have demonstrated as well. So it's technically feasible. The capability is out there. It hasn't been put into field operational testing, but the technology parts of the problem have been solved. Teledrive is really looking at the goal of if you have communications between vehicles and the infrastructure, can you provide applications that improve safety, mobility, and sustainability? So for safety, particularly with vehicle-to-vehicle, we are focused exclusively on this DSRC 5.9 gigahertz capability because that's the only communication link that can provide the low latency you need for crash imminent situations. If you have that in place, you may be able to provide environmental applications that improve sustainability, such as providing guidance to a vehicle that if you reduce your speed to a certain threshold, you'll be able to make it through all the traffic lights on this road, and therefore you'll improve your fuel economy. Also, you have this rich source of probe data for the mobility for the road operators. So that if they know where the cars are, if they know the cars are at speed, or they're stuck in traffic jams, they can either provide information to other drivers, better information than you get today through traffic information sources, or they can actually implement some of their tools by changing signal timing to improve flow, ramp metering, and other options. So it provides a wealth of mobility, safety, and sustainability options. IntelliDrive is a program, and it may, for safety, it will get DSRC put in your car. It may be other communication options. For mobility in particular, you don't have the low latency requirement. You don't need to know 10 times a second where your car is to know that you're stuck in traffic. So they may be able to leverage other communication links such as Wi-Fi or cell phone, 3G, 4G. So it could be a suite of communication options that work together to provide the whole suite of applications, safety, mobility, and sustainability. No, that's correct. 4G cannot provide the low latency you need for a crash imminent situation because with DSRC, your car sends a message directly to my car. With 4G, it has to go from my car down to the infrastructure and back to your car. And they just can't do that in the time that you'd be in a crash imminent situation. They could provide driver advisories, other situational awareness applications, such as there's a stopped queue ahead where you have more time. We need the 10 hertz update rate to get, if you just look at 10 hertz where a vehicle driving 60 miles an hour, if you're not updating your position at that rate, the vehicle moves very far and is already, the collision has already happened. The amount of ITS type technologies has reached into every area of transportation, and the amount of resources that are going into research and are just opening more and more doors for young students. If you look at my agency, NHTSA, historically we were an agency of mechanical engineers who, those were the types of engineers that worked for automobile companies. But the amount of electronics and software on vehicles is forever increasing, which requires us to have a new set of skills to understand what kind of benefits can you get from these technologies, what kind of problems do they cause, and it requires us to have a much larger cadre of electrical software engineers. It is only getting larger. Right now, up until now, we have been focused in trying to understand what's the capability of these advanced technologies, and now that we're at the point where we have feasible options, prototypes, even products on the market have been demonstrated, Now we really need to understand how these systems operate, what kind of failure modes do they have. So it's a much larger role that we need to play. It's very different when you're just trying to understand sort of the application of a black box technology as to when you actually need to understand what's going on inside of that box. Yes, we think it's very much going to be a human-centered solution. So using the technology to provide driver advisories, driver warnings, and finally some driver control, letting the system apply the brakes, but not autonomous driving. That's not a goal of the department at this time. We think we need to work through all these other issues first, as well as we don't see we don't see driver acceptance of full automation being widespread. We see large driver acceptance of effective systems. Some of the early work we did, the systems had a lot of false alarms, didn't pick up some problems, and that really damages driver acceptance of the systems. But when they get to operate a vehicle that they find helpful, they appreciate the usefulness of the technology and have indicated a willingness to actually buy the systems. We are rolling out the vehicle-to-vehicle research plan. We're about midway through that. Our next big activity is the safety pilot I discussed at this morning's meeting, which will be a model deployment of the IntelliDrive system for vehicle-to-vehicle safety applications. And this will be the first widespread, relatively large deployment of vehicles equipped with integrated safety systems within an environment of vehicles that have the DSSRC unit. In the area of vehicle-to-vehicle communications, I think we're ahead of the Europeans. The Japanese have they're more focused on the V2I capability. So I think each part of the world is leading in different areas, but we're in the front for V2V. Well, I see two big players in this area. The first are the University of California system. We've worked with Berkeley and PATH for years. And actually, on an extension of that, your State Department of Transportation, Caltrans, is a leader in this area as far as state DOTs go. And then the automobile manufacturers have all got research activities in the Palo Alto area, and that extends into the other technology companies that they're trying to leverage in that area. And they are very active in developing and deploying these systems.